The mind-boggling issue in Netflix's popular series, The Three-Body Problem, has been claimed to be solved by Alessandro Alberto Trani from the Niels Bohr Institute at the University of Copenhagen. Just as the filming of the new season has wrapped up, this new development must have worried the producers the most. If this problem is resolved, the series might turn out to be completely incorrect from start to finish. Chaotic systems where three bodies affect each other's gravity have fascinated scientists ever since the father of gravity, Isaac Newton, first identified this issue. While the interaction between two objects in space is predictable, adding a third massive object makes the movement of the trio not only complex but also chaotic. Let's also take a moment to acknowledge deterministic quantum theories, which are based on the idea that we will eventually be able to write the wave function of the entire universe, though we can't make predictions in a three-body system. Although Newton realized it was nearly impossible to resolve the gravitational effects of three bodies, the first formal recognition of its unsolvability had to wait until 1890. French mathematician Henri Poincaré made a groundbreaking revelation in his paper The Three-Body Problem and the Equations of Motion, published in the journal Acta Mathematica. He demonstrated that a full analytical solution to the three-body problem was impossible and that the system could exhibit chaotic behavior. Poincaré's work laid the foundation for the development of chaos and dynamical systems theories. Interestingly, this paper was written for a competition held by Swedish King Oscar II regarding the solution to the three-body problem. Those who have watched the series will recall a similar competition organized by a ruler from an unknown world. Before we get into the topic, let's address a frequently asked question, which will probably appear in the comments of this video. We know that the behavior of a three-body system is unpredictable. So how can we predict the movements of a solar system consisting of 9 planets and 1 star down to the minute? For the record, we are among those who consider Pluto a planet. To answer, about 98% of the solar system's mass is concentrated in the Sun. Therefore, it's possible to view the solar system as a two-body problem, the Sun and everything else. With only minor deviations, everything remains predictable, and with that, we continue with our video. In space, when three massive objects come together, they affect each other in unpredictable ways through gravity. In a word, chaos. This is the traditional understanding. But now, Trani from the University of Copenhagen claims that most of these encounters avoid chaos and instead follow orderly patterns, where one of the objects is ejected from the system at high speed. What does this mean? Let's break it down a little. The most striking statement from the paper is as follows. Our analysis reveals that regular orbits occupy a significant portion of phase space, ranging between 28% and 84%, depending on the initial conditions. Let's first explain the concept of phase space to the best of our ability. Phase space is a map of motion, containing all possible movements and states of a system. Once this is defined, the mystery is solved. As we always say, breaking down language barriers is what we do. The fact that regular orbits cover between 28% and 84% of phase space means that, under different initial conditions, a significant portion of the system's predictable movements can be foreseen, up to 84%, to be precise. This indicates that a large part of the system's movements in phase space are represented by regular orbits, although this proportion varies depending on the initial conditions. In fact, achieving an 84% solution to a problem humanity hasn't solved yet is quite remarkable. If we could solve 84% of the theory of everything, we would live in a completely different world. At the end of the day, the scientist's discovery is truly significant. With 84% accuracy is an incredible achievement. Now, you might be wondering how this astrophysicist made these predictions. Trani notes, these calculations can only be made if the initial conditions are known with complete and precise detail. That is, the positions and masses of the three bodies, as well as their angular approaches, must be fully known. Even the slightest mass difference at the quantum level between two otherwise identical three-body systems can lead to vastly different outcomes. To investigate the phenomenon, Trani developed his own software program called Tsunami, which calculates the movement of astronomical objects based on our knowledge of natural laws like Newton's law of gravity and Einstein's theory of general relativity. He used this program to run millions of simulations of three-body encounters within defined parameters. When asked how the results of these millions of simulations are evaluated, the researcher said, "We have constructed a massive map of all possible outcomes, woven together from the various initial possibilities. At this point, we observed the emergence of order islands, non-chaotic orbits. If the three-body problem were entirely chaotic, we would see only a chaotic mix of indistinguishable points and realize that all predictive outcomes were intertwined without any clear pattern. Instead, we discovered these orderly islands in the chaotic sea, where the system behaves predictably and thus produces uniform results and uniform colors. Though the explanation may seem complex, the essence is this. If you have enough computational power to simulate millions of possibilities and an algorithm that can accurately mimic nature, the resulting picture is not chaotic but rather close to order." It's also worth mentioning that when reviewing the conclusions of the research, we realize that the work isn't yet complete. The researcher notes that one of the parameter variations we haven't explored yet is the masses or mass ratios of the three bodies. Now that the problem seems solved, will Chinese author Liu Cixin, whose original trilogy was titled So with Macron T, and later translated into English as The Three-Body Problem, continue the series? If so, we'd love to hear your predictions for how the fourth book or series will continue in the comments below. See you in the next video.